Okay, so as in the last video we have discussed about the dielectric plate. If we replace a dielectric plate or we place a dielectric plate between two oppositely charged parallel plates of the capacitor, then what would be the capacitance of a capacitor? We have already discussed, right? The capacitance of a capacitor would be increased by ER times, and in the end we got our result that C is equal to epsilon naught times ER times area times per unit distance, right? So in today's video we are going to discuss the series combination, or you can say capacitors in series. So let's write our topic here. What we are going to discuss today is series combination or capacitors in series. In series, right? Series, we know that. What is series? Series means when capacitors are connected in a single path, right? In a one path. That is basically known as series. So let's connect the three capacitors in a single path, right? For suppose this is a path and here I am connecting the capacitors. So basically this is C1, right? This is positive plate of the capacitor, this is negative plate of the capacitor, right? This is C2, positive plate of the capacitor, negative plate of the capacitor. C3, consequently positive plate of the capacitor and negative plate of the capacitor, right? This is our capacitor in series. Now when two or more capacitors are connected one after that other in a same path, such type of combination is what we call the series combination or capacitor in series. Alright, now let me write the entire definition of it so that it can be more clear to us that what does mean by series combination or capacitors in series, right? When two or more capacitors are connected one after other, connected are connected one after another in a same path. This is a very important point. In a same path, right? I'll tell you what does mean by this. In a same path, such type of combination is called series combination or capacitors in series, right? Or capacitors in series, right? Right? Now let's read this definition and let's apply this to the diagram. When two or more capacitors, right? Which means we don't need to take a capacitor. However, we need to take two or more than two. Means we can take two or three or four capacitors are connected one after another, which means these two or more than two. Here we have took three, right? So I am gonna say here three capacitors. So when these three capacitors are connected, now see, they are connected one after another. First is here, second is here, third is here. So they are connected one after another in a same path. This is very important line. In a same path, which means in a single line, in a single path they are connected, right? In a same path, this is same path going on. So they are connected in a same path. This type of combination is called series combination or capacitor in series, right? Now again I am repeating for you guys, when two or more capacitors, which means when three capacitors are connected, capacitors are connected one after another, they are connected one after another in a same path. This such type of combination is what we call the series combination or capacitors in series. Right now we have a basic concept what does mean by series combination or capacitors in series. Right now let's go to understand the diagram so that we can know what we're going to discuss after this. Right, the mathematical form of series combination or capacitors in series we'll be doing in the next video, but our main motive for today's video is to understand the diagram of the capacitors in series. Right, so now let me make the diagram of the series here. This is capacitor number 1, right, connected in a single path. This is capacitor number 2, again capacitor number 3. They are connected in a single path. Right, of course they would be connected with the positive terminal of the battery, and negative plate of the capacitor would be connected with the negative terminal of the battery with provided V volt. Right, now let me mention here, this is positive terminal, this is negative terminal. Right, now of course this would gonna be connected with the positive terminal of the battery, which means here we have positive charges and here we have negative charges I'm representing with pink. Right, again here positive charges, here positive charges, and here negative charges. Right, this is C1, this is C1. Right, means capacitor number 1, C2 capacitor number 2, C3 capacitor number 3. Right, it would have a charge Q, this would have a charge Q2, this would have a charge Q as well. Right, and here we have provided, you know what, the volt potential difference V volt, right, so it will gonna have V1, V2, V3. Right, here we have connected the voltage. Right, okay, so here we have 2, and of course here we have 2. Right, so this is our diagram. Now let's understand this, and of course the potential difference would be across the capacitor. Right, across. Now consider 3 capacitors C1, C2, C3. Right, this is C1, C2, C3. We have considered 3 capacitors C1, C2, C3. They are connected in a series. Now see what is mean by series, which means in a same path. Right, C1, C2, C3 are connected in a series, which means the 3 capacitors are connected in a same path. Right, across a positive and negative terminal of the battery. See, this is connected with the positive terminal of the battery and this is connected with the negative terminal of the battery. Right, with potential difference provided V volt. We have provided it the potential difference of V volt. Right, what I have said till now, consider 3 capacitors C1, C2, C3. Right, they are connected in a series, which means they are connected in the same path. The positive terminal of the capacitor is connected with the positive terminal of the battery, and the negative plate of the capacitor is connected with the negative terminal of the battery with potential difference provided V volt. Right, then the potential difference across any member of capacitor is different, but same charge is stored on each plate of the capacitor. Now this is a very important, very important, on what you need to work on further, right? The potential difference provided to the each member of the capacitor would be different in magnitude, but the charges which would be stored on the plate of the capacitor would be same. Now we'll be continuing this in the next video. We're gonna understand its mathematical equation as well, right? So this was all for today.